disabled, and 2, all systems go systems of quadratic equations. All right, student work, excuse me, 1, 2, 3, and 4. So go ahead and work those. All right, let's take a look at the next page. All right, getting started. Block that kick. A punter kicks a football. The height of the ball in meters is modeled by the function h of t equals negative 0.9 t squared plus 20 plus 0.75. Where t represents time in seconds, a blocker can only attempt to knock down the football as it travels upward from the punter's foot. The height in meters of the approaching blocker's hand is modeled by the function h of t equals negative 0.6 t plus 3, where t represents the same time. Can the blocker knock down the football? Describe the shape of the function that models the football's height over time and the height of the blocker's hand over time. The graph of the height of the football over time is a parabola that opens downward. The graph of the blocker's hands over time is a decreasing line. All right? So now let's go ahead and sketch the graph. All right, now to sketch the graph, we're going to use Desmos. So let's come over here. So negative 4.9 x squared plus 20x plus 0.75 excuse me, negative 0.6x plus 3. Now let's adjust the window to 0 to 5 and 0 to 30. All right, let's get out of the here so we can see here. And we're looking for the points of intersection. So here and here. Now we're going to just have to sketch those points. All right. So let's graph the blue line first. So 0.1, which is about here, 0.9, again, we're just approximating. And 4.1 and a half is right here. Again, we're just going to do our best to approximate. All right, and then the parabola, we just need one more point. We can use this point. Fine, let's find the vertex. 2.0 comma 21.2. Okay. So 21.2 is about right here. All right, so there's our graph. All right, let's take a look at the next page. All right, activity 2.1, modeling a system with a linear quadratic equation. A system of equations can involve nonlinear equations such as a quadratic equation. The scenario described in previous activity models the relationship between a quadratic and a linear equation. Student works 1, 2, 3, and 4. So go ahead and write that down. All right, and then go ahead and write that down. All right, let's take a look at the next page. All right, activity 2.2. Solving a system with a linear quadratic equation. Methods for solving a system of nonlinear equations can be similar to methods for solving systems of linear equations. Consider the system of linear equations and a quadratic equation. Write a new equation you can use to solve the system, and then solve the system for x and y. So since they're both equal to y, we can say they're both equal to each other. So we have x squared plus 4 equals 2x plus 7. Now, we're going to subtract 2x and subtract 7 from both sides. Cancels. You're left with x squared minus 2x. 4 minus 7 is minus 3 equals 0. All right. Now, we know 2 parentheses equal to 0, x and x. Now, we need to figure out what numbers multiply to give you negative 3 and combine to be negative 2. Since the bigger number is negative, since the middle number is negative, the bigger number is negative. So let's try 1 times negative 3 is negative 3. 1 minus 3 is negative 2. So we have our negative 3 and negative 2. So our factors are x plus 1, x minus 3. Okay, so x plus 1 equal to 0, x minus 3 equal to 0. Excuse me. So x equals negative 1, x equals 3. Now, we need to plug the x back into either equation. I suspect that the first equation is easiest to do, so let's do that. So y equals 2x plus 7. Well, we know x is negative 1, so y equals 2 times negative 1 plus 7, which equals 5. Okay, and so again, we can just use the first equation, y equals 2x plus 7. So in this case, x is 3. So 2 times 3 is 6, plus 7 is 13. So the solution to the system is the point negative 1, 5, and the point 3, 13. All right, go ahead and finish that up. All right, let's take a look at the next page. All right, graph each equation of the system and calculate the points of intersection. So let's go and use Desmos. So y equals 2x plus 7, and y equals x squared plus 4. Now, I'm going to press the home screen to go back to the normal window. And let's go ahead and graph those points. Let's graph these points first, negative 1, 5, and 3, 13. All right, so negative 1, 5, 3, 13. That's our blue line. And we just need one more point for the parabola. Let's use the vertex 0, 4. And then we know that the parabola is going to go through these 3 points. And you can see our solutions are negative 1, 5, and 3, 13. So what do you notice about the solutions you calculate algebraically and graphically? The solutions calculated algebraically and graphically are the same. All right, let's take a look at the next page, next portion. Think about the graphs of linear equation and quadratic equation. Describe the different ways in which the two graphs can intersect and provide a sketch of each case. Two intersection points. So that will have two solutions. One intersecting point will have one solution. So, and then no intersecting point, no solution. All right, go ahead and write that down. All right, let's take a look at the next page. All right, student works 3A and 3B. All right, student works 1, 2, and 3. And then student works 1A, 1B, and 1C. All right, next page. Student works 2, 3A, 3B, 4A, and 4B. All right, go and start working on your assignment and have a wonderful Wildcat day.